Hello everyone, our project is Home Credit Default Risk Prediction. We are Group 8. We will start from the following aspects. Credit is not available to everyone who applies for a loan from a bank. The traditional way of bank is to manually consider the basic information of applicants, especially previous credit history. It contains complex procedures and may result in poor judgment. Many people who could have paid off their loans on time struggle to get loans due to insufficient or non-existent credit histories. And unfortunately, this population is often taken advantage of by untrustworthy lenders. Home Credit, which is an international finance company, focuses on responsible lending to people with little or low credit history who may be undeserved by traditional banks. It strives to broaden financial inclusion for the unbanked population by providing a positive and safe borrowing experience. In order to make sure this undeserved population has a positive loan experience, Home Credit makes use of a variety of alternative data, including technical and transactional information, to predict their clients' repayment ability. We want to use statistical and machine learning methods to predict clients' repayment abilities.
Data exploration can help us understand the data quickly, and it is useful for future engineering. The diagram shows how all the data is related. In this project, we will stick to using only the application training data and testing data, although extracting features from other data sources may help us to improve our accuracy. Since the application dataset has hundreds of features and our main goal is applying different machine learning models, we decided to try our best applying what we know in application dataset to predict. In the following parts, I will introduce how we explore application training data to find useful information. We start our process of data exploration from a high-level overview, then we narrow into specific areas to find more detailed information. The table shows the data sets. There are many attributes, which may cause training models slowly. We can consider that using PCA or similar methods to reduce dimensionalness, or we can drop these attributes which is useless in our prediction. This problem is a binary classification problem. From the data distribution figure, we can see it is imbalanced data. For imbalanced data, using accuracy to measure is not correct, because the accuracy is always high regardless of our model is correct or not. We need to find other methods to measure our model. In this project, Kaggle suggests to evaluate our predicted results on area under the ROC curve between the predicted probability and the observed target. Checking the missing rate for each attribute in dataset is important for data preprocessing. We should use some strategies to deal with those missing values. For training data, we visualize the missing rate of each clone as below. Since more than half of the clones have missing values, so we use median to fill them. To find important features, we calculate the Pearson coefficient between different attributes with target. After computing the correlation coefficients, then we explore these attributes which have relatively larger correlation values. These birds have the largest positive correlation coefficient. From the statistics of these birds, it seems that there is no outlier. Then we generate a new feature age, and we analyze the relationship between age and target. We found that old people tend to repay the loan, so age is a useful feature. This employee has large negative correlation coefficient. From the statistics, it seems that there has abnormal values, since this employee is represented by negative numbers, so we firstly transform it to positive values, then we draw its distribution. We can see that there is only one abnormal value. It may be used to represent some information, so we extract whether it has the outlier value as another feature. We also explore code gender. From the distribution, we can see that only few records have code gender equals to XNA. We those as outliers, so we just remove those records from our dataset.
Based on the exploratory data analysis, we are going to do some data pre-processing before we start to train the model. By data exploration, we found that there are some categorical variables in our data, like the contact type information and gender information. Most of the machine learning methods cannot deal with the non-numeric data, so we need to find a way to encode them. The main way of encoding data are label encoding and one-hot encoding. In label encoding, we assign each unique categorical variable with an integer. No new columns are created. This encoding method is easy to implement and will not cause the expanding of feature tables since it just replaces the variable with a label. However, the label is represented by numeric values and that it assigns each unique categorical variable with an integer while the numeric value itself having no meanings. This gives lots of meaningless information which could mislead the model if there are too many categorical variables. In one-hot encoding, we create a new column for each unique categorical variable. Each observation receives an 1 in the column for its category and 0 in other columns. This solves the problems above, but creating a column for each categorical value causes a great expansion to the feature table. It might not be suitable in the case that there are many object type features having great amount of unique categorical value. Further looking into our data, we found that amount of the 121 features, 16 of them having categorical variable, and only few of them having large amount of distinct categories. Based on these characteristics, we apply label encoding to features having exactly 2 categories and apply one-hot encoding to features having more than 2 categories. From the exploratory data analysis, we found nearly half of the columns in the dataset have missing data, and most of the attributes have more than half amount of missing data. This could lead to biased model because we have not analyzed the behavior and relationship with other variables correctly. Though there is a high missing rate, we cannot just drop those columns because they might have latent correlation and contribute to the model in some way. So to keep track of the features of missing, we create a column recording whether the values was missing before we actually fill in the values. Then we choose to fill these missing values with the median of the column, which is a statistical approach of handling missing values. It can prevent data loss, which results in removal of the rows and columns. Now we have finished the data cleaning. Before we feed the data into a model, we want to further improve the training performance by manually adding some features based on the domain knowledge. It's hard to say ahead of time if these new features will be useful, so we made some visualization of the kernel density estimation to further estimate it. First is the percentage of days employed relative to the client's age. We can see the rate is higher for those who paid on time than those who have difficulty paying loan. The percentage of clients' income relative to the credit amount and the household income per capita of the client shows great difference on the value distribution over the target. Percentage of loan annuity relative to the client's income distributed evenly over the target, and those who pay the loan on time tends to have more lower percentage. As for the length of payment in rate, it shows complexity in the kernel density estimation. We are going to examine these features in the implementation.
For the implementation part, we are going to introduce 3 models. First of all, the logistic regression model. Logistic regression is a classification algorithm used to assign observations to a discrete set of classes. Logistic regression transforms its output using the logistic sigmoid function to return a probability value which can then be mapped to 2 or more discrete classes. As for this case, binary logistic regression is introduced because the output is divided into 2 classes. After preprocessing, the logistic regression module from scikit-learn is introduced to implement the training of the logistic regression model. During the implementation, the regularization parameter C, which controls the amount of overfitting, was changed into 0.0001 in order to get a slightly better result. After the training, the trained model can be used to make predictions. For the evaluation part of the logistic regression model, part of the training data is used in performed cross-validation, then call the ROC-AUC score function in the scikit-learn model to get the area under curve of the prediction value of the model. And we can see from the result that the mean AUC is approximately 0.684. Then we will introduce the random forest model. Random forest is an ensemble learning method for classification, regression, and other tasks that operates by constructing a multitude of decision trees at training time and outputting the class that is the mode of the classes or mean prediction of the individual trees. Random forest builds multiple decision trees and merge them together to get a more accurate and stable prediction. Random forest has nearly the same hyperparameters as the decision tree or Bayesian classifier, and it adds additional randomness to the model while growing the trees. Instead of searching for the most important features while splitting the nodes, it searches for the best features among the random subsets of features. This results in a wide diversity that generally results in a better model. Therefore, in random forest, only a random subset of the features is taken into consideration by the algorithm for splitting the nodes. In this particular case, conducting the same training data to see how the random forest model affects performance. Importing the random forest classifier module from the scikit-learn package and changing the n estimated parameters to 100 in order to generate 100 trees in the forest. Then directly use the original training data used in the logistic regression to train the random forest model. For the evaluation part of the random forest model, part of the training data is used in performing cross-validation, and we can see from the result that the mean AUC is approximately 0.712. Then we will introduce the light gradient boosting machine. lightGBM is a gradient boosting framework that uses tree-based learning algorithms. It is designed to be distributed and efficient with the following advantages: faster training speed and high efficiency, lower memory use, better accuracy, support the parallel and GPU learning, and capable of handling the large-scale data. Most decision tree learning algorithm grows tree by level-wise. As for lightGBM, it grows tree leaf-wise. It will choose the leaf with max delta loss to grow. Holding leaf fixed, leaf-wide algorithms tends to achieve lower loss than level-wise algorithms. In this particular case, we will import the lightGBM classifier module from the lightGBM package, adjusting the num leaves and max depth parameters in order to make a better prediction. Then directly use the original training data used in the logistic regression to train the lightGBM model. For the evaluation part of the lightGBM, part of the training data is used in performing cross-validation, and we can see from the result that the mean AUC is approximately 0.768. At last, we will make a comparison between these three models. After submitting the predicting result to Kaggle kernels, we will be able to get a public score and a private score. We put them into a bar chart and we can discover that the lightGBM performs a little better based on the same input data.
In this project, our group members have gained a lot. Firstly, we successfully applied machine learning knowledge to practical models. And then We learn common methods of EDA, data pre-processing, and feature engineering. In addition, we try some optimization in data processing and model construction to improve accuracy. We have a clearer understanding of machine learning. Most importantly, it endows us with problem-solving ability, teamwork spirit, and high responsibility. That's all. Thank you.